The history of the solar system spans billions of years and involves complex processes of formation and evolution. Here is a general overview of key events in the history of our solar system. Let's take a deep breath and look into it in detail. First of all, we have 1. Formation, about 4.6 billion years ago. The solar system formed from a vast rotating cloud of gas and dust called a molecular cloud or nebula. Some triggering event, such as a nearby supernova or shockwave, caused the nebula to collapse under its own gravity. The collapsing material formed a spinning disk with a central concentration that eventually became the Sun. 2. Formation of the protostar and protoplanetary disk. The central concentration in the spinning disk became the protostar, which would later become our Sun. The surrounding material in the disk began to clump together due to gravitational forces, forming protoplanets and other small bodies. On third, we have planetesimal formation. Within the protoplanetary disk, solid particles collided and stuck together, forming planetesimals, small building blocks of planets. These planetesimals continued to collide and merge, leading to the formation of larger bodies. On number 4, we have planet formation. As the protoplanetary disk cooled, materials began to condense and solidify. Larger bodies, known as protoplanets, continued to grow through accretion, attracting more material through gravity. Over time, the protoplanets became the planets we recognize today. Then we have clearing of debris. The early solar system was filled with leftover debris, including smaller planetesimals, asteroids, and comets. The gravitational influence of the newly formed planets and the solar wind from the young Sun helped clear much of this debris from the solar system. Late heavy bombardment, 3.8 to 4.1 billion years ago. During this period, the inner planets, including Earth, experienced a high rate of impacts from leftover planetesimals. This period of intense bombardment contributed to the shaping of planetary surfaces and may have played a role in the development of conditions conducive to life on Earth. Stabilization and evolution. Over time, the solar system stabilized and the planets settled into their current orbits. The Sun entered its main sequence phase, where it continues to shine as a stable hydrogen-fusing star. The planets underwent geological and atmospheric processes that shaped their surfaces and climates. Continued evolution and exploration. The solar system continues to evolve, and ongoing observations and space missions provide new insights into its dynamics. Robotic spacecraft have explored various celestial bodies, including the Moon, Mars, Venus, Jupiter, Saturn, and their moons. Certainly, let's delve into more detail about the key components of the solar system. The Sun history of the Sun. Formation, approximately 4.6 billion years ago. The Sun formed from the gravitational collapse of a region within a large molecular cloud of gas and dust. As the collapsing material gathered at the center, it formed a spinning disk, and the central core eventually became the Sun. Early solar system. The Sun's formation was a key event in the early solar system, setting the stage for the accretion of planets, moons, and other objects from the surrounding protoplanetary disk. Present state of the Sun. Structure. The Sun is a G-type main sequence star, commonly referred to as a yellow dwarf. It consists of several layers: the core, radiative zone, convective zone, photosphere, chromosphere, and corona. Nuclear fusion. In the Sun's core, nuclear fusion reactions convert hydrogen into helium. releasing immense energy in the process. The sun's energy output is sustained by the balance between gravitational forces compressing the core and the outward pressure generated by nuclear fusion. Sunspots and solar activity. Sunspots, dark regions on the sun's surface, are areas of intense magnetic activity. The sun undergoes an approximately 11-year solar cycle marked by variations in sunspot numbers and solar activity levels. Solar wind. The sun constantly emits a stream of charged particles known as the solar wind. The solar wind interacts with planets, comets, and other celestial bodies in the solar system, influencing their atmospheres and magnetic fields. Solar atmosphere. The sun's atmosphere comprises the photosphere, visible surface, chromosphere, and corona. The corona, the outermost layer, is much hotter than the sun's surface, and the mechanism behind this temperature difference is a topic of ongoing research. Future of the sun, main sequence. Phase. The sun is currently in the main sequence phase, where it fuses hydrogen into helium in its core. It has been in this phase for about 4.6 billion years, and is expected to remain in the main sequence for a total of about 10 billion years. Expansion and red giant. Phase. In about 5 billion years, as the sun exhausts its hydrogen fuel, it will undergo changes, expanding into a red giant. During this phase, the sun will become much larger, potentially engulfing the inner planets, including Mercury and Venus, helium burning, and planetary nebula. In the red giant phase, helium burning will occur in the sun's core. After this phase, the outer layers of the sun will be ejected into space, forming a glowing shell of gas known as a planetary nebula. White dwarf, what remains of the sun's core after the planetary nebula phase, will contract into a dense, Earth-sized object called a white dwarf. The white dwarf will gradually cool over billions of years, becoming a dim, inactive remnant.